Greetings, math fans. All right, so this is day 2. These are special cases of using inverse or arc trig functions. Let's talk about our first case here. Okay, our first case is going to be where the arc or the inverse is inside. And this is what I mean by this. I'll say the sine of the arc cosine of 5 over 13. Okay, now I know some of you guys are going, what? I don't know what that angle is, right? We never covered an angle like that. Well, here's the deal. What I'm really asking is, I'm finding the sine of some angle that I will never know. Okay, so this is kind of like a theta here. It's like sine of some theta. Well, what we're going to do is we're going to draw a picture. And that picture, this guy right here, is based on that arc cosine. So we already talked about our range chart, okay? And we know cosine is going to be in these two quadrants. It's negative here and it's positive here. Okay, well this is positive here. So when I draw my picture, I'm going to draw it in the first quadrant. So we know cosine is x over r, so 5, 13, and then of course this is a 5, 12, 13 triangle. Okay, and then this is my theta. So I don't know what that angle is, but I know what the triangle looks like, and then I can say, hey, what's sine of that? What's sine of that? Yeah, that theta, and sine of theta is y over r. So the answer to this problem, then it's going to be 12 over 13. So that whole answer is 12 over 13. That's how you do that problem. Okay, but notice when I said again that the arc is on the inside. Okay, we're going to cover that for the second case where the arc is on the outside, but now the arc or the inverse trig function is on the inside, so it's the sine of some angle. Okay? All right, so let's try another one here. Sine of the arc cotangent of negative 3/5. All right, so again, it's the sine of some angle that I don't know. So I need to make a sketch. Well, it's arc cotangent and it's negative. So do you guys agree that arc cotangent negative is going to be here? Right? Because of cotangent goes with cosine, right? It's cosine over sine. So just again, looking at the range chart. And then, of course, you know cotangent is the xoi. So it's going to be negative 3 and 5. And then this is going to be using Pythagorean theorem, root 34. Okay, so this is my theta, and then I say, well, what's sine of that angle? Well, sine again is y over r, so it's 5 over root 34, which is 5 root 34 over 34. Okay, once again, I'm going to point this out. It's on the inside. Okay, the inverse trig function, arc cotangent, is on the inside. Those are kind of easy. So the key to these problems, math fans, the key, and you guys know what a key looks like. Okay, the key is you got to draw a picture. Okay, that's huge. So you draw, basically you're drawing your triangle. Okay, and you're making sure it's in the right quadrant. All right, because again, that arc cotangent dictates that it's in that quadrant. Now, if this, let's say it was arc instead of that. I'm not going to do the whole problem. Well, let's say it was sine of the arc tangent of negative 3/5. Well, that means you draw the picture in this quadrant here. Well, maybe I will do the whole problem. Okay, if you draw it in that quadrant, so you know it's the yax, so it's negative 3, 5, and then this is going to still be root 34. But now when I take the sine of that, it's y over r. So of course this 3 is going to be negative here. Right, so it's negative 3 over root 34, which is negative 3 root 34 over 34. Okay, so again, this dictates where you draw it, and then you find your theta by just using your ratios. Okay, so that's pretty mellow. That's our first special case. Let's do it where the arc is on the outside. Okay, so the arc or inverse is on the outside. Okay, this is actually more difficult. I'm just going to put it out here. More difficult. Because the other one's easy. You just draw a picture and then kind of get your ratio. All right. I'm going to make a huge point of this. In fact, I am going to put this in a bold red. Is the answers must be in range. Okay, when you see inverse cosine on the outside of I don't care whatever it is, your answer better be between 0 and pi. Okay? If it's not between 0 and pi, then your answer's wrong. I'm going to put an R next to your problem because it's out of range. Okay, same thing with sine. If it's inverse sine or inverse cosecant or inverse tangent, right, that better be between negative pi over 2 and pi over 2. Okay, if it's not, if that final answer is not between those values, I'm going to put a big old R next to it. All right, and standing for a range. You're not in the range because you didn't give it to me between these two values. Very, very, very important. Okay, it's got to be in the range. All right, so let's start with a nice little friendly example here. I'll switch back to black so we don't scare everybody. Arc cosine of the cosine of pi over 3. So let's just talk about, let's do it, let's do it manually first, okay? And then I'll kind of show you a little bit of a shortcut, and then I'll even show you even a better shortcut. Well, probably really one shortcut here. What is the cosine of pi over 3? So this is from chapter 3 when I first introduced radians, right? So this is like really, really easy. Cosine of pi over 3 is reference angle, of course, 60 degrees. Cosine of 60 is 1/2. So do you guys agree this is 1/2? And then I ask, what is the arc cosine of 1/2? And this is like before, right? Now you're saying, hey, the cosine of what is 1/2? It's positive. So remember, we have our steps here. Our first step for this problem is look at the sign. So it's positive. Second step is find your reference angle. Well, the cosine of what is 1/2? And it's going to be pi over 3. You guys agree with that? And then the third step is use the range chart. And if I use the range chart, well, that's easy. If it's positive, it's a blow-off right here. It's just the answer is just pi over 3. That's my answer. Now, some of you guys are looking at going, wait a second. What the heck, man? It's the same thing. It's like it canceled it out. And you're right. It did cancel out. That arc cosine does cancel out the cosine. Almost all the time, right? What's the main thing here? It's got to be in range. So if I do another problem, arc cosine of the cosine of 2 pi over 3. Is that going to cancel it out? It sure is, because isn't that 2 pi over 3 in range? Yeah, so my answer is 2 pi over 3. Okay? Let's do another one here. Arc cosine of the cosine of 4 pi over 3. So if you went, oh, cool, it cancels out, and you wrote 4 pi over 3 there, okay, what am I going to do? I am going to, in big red letters, I'm going to write an R here and mark it wrong. Okay, because that is not in range. Cosine is between, inverse cosine is between 0 and pi over 2. Or, sorry, and pi, right? And that's 4 pi over 3. It's greater than pi. So you guys, you need to understand that your final answer has to be between, in this case, 0 and pi. Okay? So you got just a little bit of work to do. Not a lot, but just a little bit. So let's talk about the work you do need to do. Well, again, we can kind of do it manually here. All right, let's do it manually one time, and then I'm going to show you kind of a little bit of a shortcut. It's kind of nice. Well, cosine of 4 pi over 3. Do you guys agree? First of all, what's the sign of that? Okay, and that's over here, right? 4 pi over 3, and cosine of pi over 3, 60 degrees, so it's 1/2. But of course, it's negative 1/2. So it's arc cosine of negative 1/2. And now it's just what we did before, is arc cosine of negative 1/2. Well, the cosine of what is 1/2? So we got three things here. We got one is we got to determine the SIGN, which you'll look at it and go, oh, it's negative. The second is cosine of what is 1/2? Well, the reference angle is pi over 3. And then the third step is you go to the range chart. Well, of course, if it's negative in pi over 3, aren't you going to over here? So isn't it pi minus the reference angle, which is 2 pi over 3. So that's my answer to this problem. It's not 4 pi over 3, it's 2 pi over 3. Okay? And you're like, well, okay, that, I can deal with that, right? If it's not in range, I have to kind of do a little bit of work. So let's talk about maybe a little bit of a shortcut here. Okay? And this is only when you have the same value. You have arc, cosine, and cosine. If it was like arc, cosine, and sine, you can't do that. If it's like it cancels it out, but not really. So let's talk about a little bit of a shortcut here if you have them the same like that. So let's actually do this exact same problem. Arc cosine of the cosine of 4 pi over 3. Okay, again, the same, arc cosine, cosine. We're going to do, our first step is you're going to determine the SIGN. So SIGN, and that's just basically doing all students take calculus. Okay, and of course 4 pi over 3 is over here. So do you guys agree? It's negative. That's the first thing you're going to do. The second step is you're going to find the reference angle. And guys, the reference angle is so easy, especially in radians. It's so easy. When it's in degrees, it's a little more, a little more difficult. But man, radians is awesome because what do? You literally look at the bottom number. So I know my reference angle is pi over 3. That's so easy. Oh. So if it was, 10 billion pi over 3, what's the reference angle? Pi over 3. Really, really easy. Okay, and then the third step is use the range chart. Okay, and it's negative and it's pi over 3, so it's going to be pi minus pi over 3, which is 2 pi over 3. Okay, so we got the exact same answers before. This is just, again, it's a little bit of a shortcut. So let's do a couple more of these problems with the shortcut. We'll keep one right on here. Let's do, how about this one? Inverse cosine of the cosine. Once you remember, inverse, same thing as arc, right? Inverse cosine of the cosine of negative pi over 3. Okay? Is that in range? No. That's really the question you always ask. So the question, because if it is in range, then you're done with the problem. You just say that's the answer. But the question is negative pi over 3 in range for inverse cosine. And it's not, so no. So that's why you have to do these 3 steps up here. Again, it's pretty easy. The first step is, what is the sign? Well, a couple things here. Isn't negative pi over 3 here? So isn't cosine positive here? Second step was the reference angle. Well, let's look at the bottom number. Oh, it's pi over 3. Okay. Third step, use the range chart. Okay, and if I use the range chart, it's positive pi over 3, so I'm over here, right, the first quadrant. Well, the answer is just pi over 3, right? There we go. So I could have done something a little bit simpler. Again, I'm just trying to use some prior knowledge here, math fans. Do you guys agree that this guy right here, cosine of negative pi over 3, what can I write that as? Cosine of pi over 3, because cos is pos. So I really could have rewritten this problem even before I started anything as this. Okay, is that in range now? Oh, it sure is. So the answer is pi over 3. So we got the exact same answer, just a little bit different way. Okay? Alright, so I got a bunch more here I want to do with you guys because I think it's good practice. Inverse cosine of the cosine of 20 pi over 3. Brutal! Well, I would probably do coterminal and bring it down to something more manageable. So I would subtract 6 pi over 3 3 times. So it's like subtracting 18 pi over 3. So this is equal to inverse cosine of the cosine of 2 pi over 3, right? So again, we're doing minus 18 pi over 3, which is 6 pi over 3, right? Or 6 pi. So again, we're doing coterminal. Well, okay, so we're at this point here. Is 2 pi over 3 in range? Sure is. Woohoo! 2 pi over 3 is our answer. Oh yeah. Okay, here's another one for you. Let's try a different trig function. Inverse tangent of the tangent of 5 pi over 6. Okay, is 5 pi over 6 in range for tangent? It is not. Tangent is between negative pi over 2 and pi over 2, so it's not in range. You got to do 3 steps. First step, let's see, 5 pi over 6. You guys agree it's over here? And what is tangent here? All students take calculus. Tangent's negative there. Okay. Second step, what's a reference angle? That's the easiest thing I could possibly give you, pi over 6. Third step, use chart. Okay, so if you use the range chart, it's negative, it's pi over 6. Do you guys agree tangent is down here? So it's negative theta prime. So my answer is negative pi over 6. Okay? Not too bad, right? Okay, let's keep going here. How about inverse cotangent of the cotangent of 5 pi over 6? Is that in range? Yeah, it is. It is in range, right? Okay, because 5 pi over 6 is over here, and cotangent is over here along with cosine and secant. So my answer is 5 pi over 6. Those are really nice when they're in range. Okay, but you're not going to get too many of those. Inverse secant of the secant of 3 pi over 4. Secant goes with cosine. Is that in range? Sure is. I know you're getting a little bored. Okay, but that's okay. Okay, so inverse secant of the secant of negative pi over 4. Is that in range? Nope. It's not in range. So please do not tell me it's negative pi over 4. You got to do a little bit of work. Okay, first step, the sine, SIGN. Well, do you guys agree that negative pi over 4 is over here? And its cosine, isn't cosine positive here? In fact, even before I go any further, math fans, cos is pos, but it also works with its reciprocal function. So can't you just do this? Yes. And now we're in range. Okay, you'd gotten that no matter how you did it, right? Okay. Not too bad. Let's see here. Let's try a couple more. Let's do one that's not necessarily you don't have a reference angle. So let's do inverse sine of the sine of pi. Well, is that equal to pi? Well, no, because again, we're over here. Okay, and the range for sine is between here and here. So it's not equal to pi. Okay, so you got to do a little bit of work. And basically you're saying, it's kind of like doing it the old way because you have no reference angle. So you're saying, hey, what's the sine of pi? Isn't the sine of pi 0? So I have that. And then you go back to this problem and say, hey, the sine of what is 0? Right? And wouldn't you say it's the sine of 0 radians is 0? So it's equal to 0. So this whole thing, it's not pi, it's equal to 0. Okay? How about let's do that one for cosine. Inverse cosine of the cosine of pi. Is that in range? Yep. From 0 to pi. So we're good to go. How about this one? Inverse sine of the sine of 2 pi. In range? No. But, can I just do coterminal? Can I write that as a sine of 0? Hey, alright. So my answer is 0. Okay. Let's do a few more here. How about inverse cosine of the cosine of pi over 105? What? Ugh. Oh, that's easy. Is that in range? Sure is. Isn't pi over 105 like almost at 0? So the answer is pi over 105. It's all in range. How about this one? Inverse cosine of the cosine of 104 pi over 105. Is that in range? Sure is. It's right about here. It's almost at pi. So it is 104 pi over 105. Okay? Couple more. Don't go away. Inverse sine of the sine of 12 pi over 25. Where is that located? Do you guys agree 12 pi over 25 is a little bit less than half, right? Because 12 and a half is half of 25. So 12 pi over 25 is almost half, but it's still in the first quadrant. So don't you guys agree? It's 12 pi over 25. Okay, because it's in range. All right. Let's do. I've showed you all the problems where it's the same. So sine, inverse sine, and cosecant, inverse cosecant, secant, cosecant. So they're all the same. But if I give you something like this, inverse cosine, or the sine of 4 pi over 3. Okay, remember it doesn't just cancel out here, math fans, because these are different trig functions. Okay, so you have to kind of do the old-fashioned way here, and it's not a big deal. I mean, again, it's sine of 4 pi over 3. What is that? Okay, well, it's sine of 60 degrees, and sine of 60 is root 3 over 2, but we're over here. So do you guys agree that this right here, again from chapter 3, I would say the sine of 4 pi over 3 is negative root 3 over 2. Okay, and then you do the inverse cosine of that. So remember what I said to do is look at the sine. That's easy. It's right there. So it's negative. What is a reference angle? So the cosine of what is root 3 over 2? Well, isn't it pi over 6? Right, 30 degrees. And then you have the negative. So negative pi over 6, and then I look at the range chart. And so I'm negative in pi over 6. Don't you guys agree I'm over here? Okay, because cosine is negative here, and the range chart says pi minus the reference angle, or pi minus pi over 6. So my answer to this problem, actually this top guy here, is 5 pi over 6. Okay, it's a little bit longer when these are different. Okay, these are different trig functions. A lot faster when it's inverse cosine to the cosine. So I tried to show you a shortcut. If they're different, there is no shortcut here, and you have to kind of do a little bit more work. And remember chapter 3 and, of course, chapter 6. All right, so real quickly, math fans, this unit right here, remember when arc is on the, and these are all problems where arc is on the inside, or arc is on the outside. Arc or inverse. This is outside. Okay. The stuff I did in the beginning was arc or inverse is on the inside. That's where you draw a picture. There's not really a picture here. Maybe a little bit for getting the range chart or figuring out all students take calculus, but otherwise it's a picture when the arc is on the inside. Think of it as Noah's got his ark on the inside, and you want to take a picture of that ark before he goes out to sail. Once it's on the outside, you're all in water and nobody's taking a picture of it. Okay, you're on land. You want to take a picture of it on the inside. So if it's in the inside, you're taking a picture. If it's on the outside, there's no picture because the ark's floating already. Okay. So anyway, that is it, math fans. I hope you kind of pick up on a lot of the stuff. It's not necessarily that easy, but it's not that brutal either. All right? Anyway, have an outstanding day, math fans. Adios. Goodbye.